Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. In the quiet vastness of the night sky, the stars twinkle as if they hold a secret, a silent song that only the universe understands. Imagine for a moment the coolness of the night air brushing against your skin, the soft hum of the world around you, and then there they are, these ancient lights scattered across the heavens like distant whispers from another time. They have travelled so far for so long, carrying the stories of the cosmos, stories that we are only beginning to understand. Each star is like a small sun, a furnace burning so hot that it fuels the very fabric of the universe. Yet the light we see is not the same light that is born in the heart of these fiery giants. The light we gaze upon is, in a way, a messenger. It travels from the star, journeying across the cold emptiness of space, for sometimes millions, even billions of years, before it finally reaches our eyes. It is as if these stars are sending us postcards from the past, messages frozen in time arriving long after the event has occurred. Think of the light like a traveller on a long and lonely road making its way across an endless dark desert. The closer it gets to us, the more it carries the imprint of its journey. Some of it might be faint, some of it might be bright, but each photon has a history, a story to tell. This story is shaped by the very nature of light itself. Light, as we know, is not just something we see, it is energy, travelling through space in waves, but also in tiny packets called photons. These photons can carry the most incredible information. When they are born from a star, they contain the essence of that star, its temperature, its composition, and the path it has travelled. It is as if the stars are not just sending us light, they are sending us their memories, their very life's essence, preserved in those beams of brilliance. Now imagine for a moment the journey these photons undertake. They travel through space at the speed of light, a speed that we cannot even fully comprehend. In just a second, light can travel nearly 100,000 kilometers, faster than anything we can even begin to imagine. But this isn't just about speed, it's about time, because light doesn't just move, it shapes the very nature of how we understand the past, present, and future. You see, when we look up at the stars, we are not looking at them as they are right now. We are looking at them as they were when the light first left their surface. For stars that are thousands of light years away, we are gazing back in time. The light from a star that is 1,000 light years away has taken 1,000 years to reach us. That means when we see that star's light, we are seeing it as it was 1,000 years ago. In a way, it's like time travel. The light that reaches us brings the past into our present, and with it, the history of the universe. The stars are like time capsules, containing the memory of a time long gone, and it is through this light that we are able to piece together the story of the cosmos. With each glance upward, we are not just looking at points of light, we are looking at a history that stretches back eons, a story written in the language of photons. But there is another layer to this story, a deeper mystery that lies hidden in the very fabric of the light itself. Light, in all its beauty, carries with it more than just the essence of distant stars. It also carries the imprint of the universe's most hidden forces, forces that we are only just beginning to understand. For example, have you ever noticed how the stars twinkle? To the naked eye, the stars appear to shimmer, their light flickering as it travels through the Earth's atmosphere. This is an effect of the air's movement, the constant shifting and flowing of gases in the atmosphere. The stars are not actually blinking, they are steady, burning steadily in the cold of space. But as their light passes through the layers of our atmosphere, it gets bent and refracted, causing the twinkling effect we see. But there is something more profound at play here. As the light travels through space, it can also encounter other forces. The universe is not empty. It is filled with invisible fields and mysterious energy. Some of these forces can bend the path of light itself, a phenomenon known as gravitational lensing. When light passes near a massive object like a galaxy or a black hole, its path is bent, stretched, and distorted, creating an effect that warps the light from distant stars, turning it into arcs or halos of light. In these moments, light reveals its hidden potential to be shaped, to be transformed, to be bent by the gravity of massive objects. It is in these subtle distortions that we see the deepest secrets of the universe, the hidden structures of space-time itself, and as we study the way light behaves, we begin to understand more about the very nature of the universe, how it is connected, how it bends, how it dances in ways we are only just beginning to comprehend. Light is more than just a way to see, it is a connection to the universe's deepest mysteries. Each beam that reaches us, each photon that arrives, is a thread that ties us to the farthest reaches of space, to the unknown edges of time, and to the very heart of the stars themselves. And perhaps, in some quiet corner of the universe, the light that we see today is already beginning its journey, preparing to tell us the stories of tomorrow. Now, as we move deeper into the mysteries of light, let us imagine for a moment that we are no longer just observers of the stars, but participants in their timeless dance. Picture the vast, sprawling universe, stretching endlessly in all directions. The stars, these radiant beings, are not just shining far away, they are in a way part of the very fabric that makes up the universe itself. Their light is not only the source of our gaze, but also a reflection of something much more profound, a fundamental connection that binds the cosmos together. In a way, light is the messenger that links everything. Each beam, each photon travels across the universe carrying with it a piece of the story, a thread of existence that ties everything from the smallest particle to the largest galaxy into one unified dance. This idea of light as a bridge between all things is not just a poetic thought, it is deeply rooted in the science of the universe. Light's journey across space is not a simple one. The vastness of the cosmos is filled with empty spaces, yes, but it is also filled with intricate webs of energy. Between stars and galaxies, the space is not truly empty. There are particles, magnetic fields, and radiation that stretch across the expanse, creating a delicate, invisible web that light must navigate. As light travels, it interacts with these unseen forces. It is gently nudged, slowed, and sometimes even redirected. Yet even with all these subtle forces acting upon it, light continues its path, unchanged in its purpose, to carry knowledge, to reveal what is hidden, and to connect the dots of the universe's vast, mysterious story. Imagine that light travels in waves, undulating through space, much like a ripple moving across the surface of water. These waves carry information, each crest and trough representing a moment in the ongoing dialogue between the universe's most fundamental forces. And yet, while we often think of waves as gentle and continuous, light behaves in a way that is far more complex than we can see. For light, despite travelling in waves, is not just one uniform stream of energy. It is made of tiny, indivisible packets called photons, each carrying its own story, its own energy, and its own identity. These photons, like tiny messengers, travel together in a beautiful harmony, creating the light we see. But light is also mysterious. It can act like a wave, spreading out and gently bending around objects, and yet it can also act like a particle, carrying with it the peculiar traits of matter. This dual nature of light, where it behaves both as a wave and a particle, is one of the greatest mysteries of modern physics. Scientists call this the wave-particle duality, and it challenges the very way we understand the universe. It is as if light, in its infinite wisdom, is reminding us that the universe is far more than just what we see and understand. It is filled with paradoxes, with things that cannot be explained in simple terms. And yet this very mystery is what makes light so extraordinary. It reminds us that there is so much more to the universe than meets the eye. When we look at the stars, we are not just gazing at distant suns. We are connecting to something much greater, to the grand patterns of existence, to the forces that shape reality itself. Each photon that reaches us carries a history, a story that is so much older than we can imagine. It is a story that takes us back to the birth of the universe, to the very beginning of time itself. Imagine that in the light from distant stars there is the echo of the very first moments after the Big Bang. Light, which began as a faint glow in those early chaotic moments, has travelled through the vast emptiness, growing more and more distant from its origin, but carrying with it the traces of its birth. This is why light is not just a thing we see, it is a glimpse into the past, a reflection of the universe's deep history, and a bridge between the present and the beginning of everything. There is a quiet beauty in knowing that the light we see today has travelled so far, touching so many parts of the universe. It is a reminder of how interconnected everything is, of how each star, each planet, and each life form is part of a greater whole. The universe is not a collection of isolated parts, but a single interconnected web, where every photon of light carries with it a small piece of that unity. As we look out into the night sky, we are not just seeing stars. We are witnessing the unfolding story of the universe, told through the gentle whispers of light. Each star that twinkles in the sky is like a quiet message, reminding us that we are all connected, that the light we see today has been travelling for eons, and that in some small way, we are part of a much greater story. In this way, the light that dances in the stars is not just a visual experience, it is a reminder that the universe is not as distant as it seems. Through the stars, we are intimately connected to the past, to the cosmos, and to the very fabric of reality itself. Every time we gaze upon the night sky, we are participating in this grand cosmic dance as light travels across the universe, carrying with it the ancient stories of the stars, and in doing so bringing us closer to the quiet mysteries that lie beyond our understanding. As we drift deeper into the glow of distant stars, let us pause and reflect on what we have learned, on the quiet mystery that the light carries with it. It is not just a tool of observation, nor is it simply the product of burning matter. Light is a thread that links us, as tiny observers, to the entire universe. It is as if the universe, through its vast silence, is speaking to us softly. The stars have no voice, yet their light speaks to us in ways that words never could. With every photon that leaves a star, a moment in time is captured and set into motion. As the light travels through space, it not only reveals the story of that star, but also a deeper, more profound connection between all things. It is through light that we come to understand the universe's structure and the forces that shape it. Without light, we would be blind to the intricate web of galaxies, stars, and planets that dance around us. But with light, we see the poetry that lies hidden beneath the surface. The universe, with all its vastness, seems so distant, so unreachable. Yet, in the light that we observe from the stars, there is a bridge, a connection that brings the farthest corners of the universe into our reach. The light allows us to peer into the deepest realms of space, to look back in time, and to study the origins of life itself. It is as if every photon is a small piece of a puzzle, slowly being placed into the grand mosaic of understanding. And as we gaze into the night, the stars remind us of something deeper. They remind us of our own smallness in this vast cosmos, but also of our deep connection to it. We are, in a sense, made of the same stuff as the stars. Our atoms were once forged in the hearts of the ancient supernovae, the very explosions that create new stars and give birth to the elements that make up everything we know. The light from those stars has travelled through time, crossing vast distances and reaching us here on Earth, where we too are made of the same stardust. There is something deeply humbling in this realization. When we look at the stars, we are not just seeing the past, we are seeing the very essence of life itself, reflected in the light that has travelled across eons to find us. In that light, we are reminded of our origins, of the cosmic dance that has been unfolding for billions of years. We are not separate from the universe, we are part of it, and as the light continues to travel, it connects us to the future as well. Each moment, each photon of light carries with it the possibility of new discoveries, new understandings, and new ways of seeing the world. And yet the more we understand, the more we realize there is still so much to learn. Light, in its infinite complexity, continues to hold secrets we have yet to unlock. We are just beginning to explore the true nature of light, its behavior, and the ways it interacts with the universe. And as we peer deeper into the night sky, we are reminded that while the stars may seem eternal, their light too is fleeting. Stars live and die, and with them the light they emit. And yet, in their death, they create the building blocks for new stars, new life, and new mysteries to explore. As we sit under the blanket of stars, we are not merely passive observers. We are participants in this grand cosmic story, woven together by the very light that allows us to see and understand the world around us. The light that dances in the stars is not just a spectacle, it is a message, a reminder, and a gift. It connects us to the past, to the far reaches of the universe, and to the deep, eternal dance of existence. The more we learn, the more we realize that we are a part of something far greater than ourselves, something that stretches beyond time and space. The light that shines in the stars is, in the end, a reflection of the universe's quiet, enduring beauty. And so, as we stand beneath the stars, we are not alone. The light from distant suns is a reminder that the universe is alive, that the dance of creation is ongoing, and that we too are part of this ever-unfolding story. The stars, in their quiet brilliance, remind us that we are not just watching the universe unfold, we are part of it, and through the light, we are connected to every moment, every star, and every corner of the cosmos. In the quietest corners of reality, where the boundaries of time and space blur, lies a world so strange, so bewildering that it feels like a dream. This is the realm of quantum mechanics, where the ordinary rules of physics give way to the extraordinary. In this world, particles do not behave as we expect. They exist in states of uncertainty, where their true nature is not defined until we observe them. Imagine for a moment standing at the edge of this unseen world, where every step you take could reveal something new, something unexpected. In the macroscopic world, we are accustomed to objects having clear properties. A rock has a size, a shape, and a weight. A tree grows taller over time, its leaves swaying in the wind. We experience these things directly with our senses, but in the quantum world, everything behaves differently. Here, particles such as electrons, which make up everything we see and feel, do not have precise positions or speeds. Instead, they exist in a state of possibility, a haze of probabilities, until we measure them. This strange behavior is known as the uncertainty principle, a term coined by the physicist Werner Heisenberg. It tells us that the more precisely we know one property of a particle, like its position, the less precisely we can know another property, like its velocity. Imagine trying to pinpoint the exact location of a cloud. It is not just in one place, but in many places at once, a swirling mass of possibilities. The cloud shifts and changes with each passing moment, making it impossible to define its exact location. This is how particles behave in the quantum realm. They are not confined to one location or one speed. Instead, they exist in a superposition, a state where they can be in multiple places at the same time. It's only when we observe them, when we interact with them, that they collapse into a single state, choosing one location and speed, like a cloud that finally settles into a distinct form. This behavior is a direct challenge to our understanding of reality. In our everyday lives, things seem solid, predictable, and concrete. We know that a ball thrown into the air will eventually fall to the ground because of gravity. But in the quantum world, these simple truths do not apply. Here, particles can be in more than one place at once, and they can even be entangled, meaning that the state of one particle can be linked to the state of another, regardless of the distance between them. This phenomenon, known as quantum entanglement, was described by Albert Einstein as spooky action at a distance. In simple terms, it means that two particles, no matter how far apart they are, can influence each other instantly. as if they are connected by an invisible thread that transcends space and time. To understand this, imagine two friends playing a game of catch. They throw the ball back and forth, and no matter how far apart they are, the ball always reaches its destination. But in the quantum world, the relationship between particles is not so straightforward. If two particles are entangled, the state of one particle is tied to the state of the other. When something happens to one particle, the other particle will respond instantaneously, even if they are light years apart. It is as though the two particles are connected by an invisible force, a force that defies our conventional understanding of space and time. This phenomenon, though perplexing, is not just theoretical. It has been demonstrated experimentally, confirming that particles really can be entangled. The implications of this discovery are profound, hinting at a deeper connection between the fabric of reality. Some scientists believe that quantum entanglement might hold the key to understanding the true nature of the universe, while others suggest that it could eventually lead to breakthroughs in technology, such as quantum computers that can solve problems far beyond the reach of today's machines. But the quantum world does not only challenge our understanding of space and time, it also challenges our perception of reality itself. At the quantum level, particles do not behave in predictable ways. They are governed by probabilities, not certainties. This has led some physicists to question whether the universe is truly deterministic, as we once believed, or whether it is instead shaped by chance and possibility. Could it be that the very fabric of reality is more fluid and uncertain than we could have ever imagined? As we explore these strange ideas, we find ourselves confronted with a universe that is far more mysterious than we had ever anticipated. The quantum world does not fit neatly into the boxes of our everyday experiences. It is a place where things exist in a state of possibility, where reality is constantly shifting, where the very act of observation changes what we see. In this way, the quantum world mirrors the deepest questions of existence. What is real? What is illusion? And what lies beyond our understanding? And yet, even as we delve into the depths of this strange realm, we are left with more questions than answers. We are, in many ways, only beginning to scratch the surface of quantum mechanics. The more we learn, the more we realize that there is so much we still do not know. The quantum world is a realm of infinite possibility, and as we venture further into its mysteries, we find that each discovery only leads to more questions. But perhaps in this very uncertainty lies the beauty of the quantum world. The fact that it refuses to be fully understood, that it remains an enigma, ever shifting, ever elusive, like the dream we cannot quite grasp. As we delve deeper into the quantum world, the mysteries grow more profound, more bewildering. Imagine for a moment that you are a traveller, journeying through a landscape where the very rules of reality seem to bend and shift. You walk along an invisible path, one that is defined not by physical landmarks but by possibilities. This is the essence of quantum mechanics. The world exists not as a series of fixed, unchanging objects, but as a swirl of potential, a dance of probabilities that could unfold in any number of ways. One of the most perplexing aspects of this world is the concept of wave-particle duality. It tells us that light, once thought of as merely a wave, can also behave like a particle, with discrete units of energy called photons. Similarly, particles like electrons, which make up the atoms that form everything we see, can act as both waves and particles depending on how we observe them. This duality challenges the very nature of what it means to exist. Are these particles particles or waves? Are they solid objects or fleeting possibilities? The answer, as with so much in quantum mechanics, is both. In the quantum world, things are not confined to one identity. They are both wave and particle at the same time, a concept that is difficult for our human minds to fully grasp. Take, for instance, the famous double-slit experiment, one of the most iconic demonstrations of wave-particle duality. In this experiment, a beam of light or a stream of particles is fired at a barrier with two slits. When observed, the particles behave like tiny objects passing through one slit or the other. However, when we do not observe them, the particles seem to pass through both slits at once, creating a pattern on the other side that suggests they behaved as waves. This behavior is confounding, for it implies that the act of observation itself plays a crucial role in determining the nature of reality. Without an observer, particles exist in a state of both possibility and uncertainty, behaving as if they are everywhere at once. It's as if the universe is holding a secret, one that it only reveals when we are looking, when we are paying attention. The very act of observation, it seems, causes the wave of possibilities to collapse into a single reality. In this way, the quantum world is not merely a passive space. It is an active, living thing, one that reacts to our presence, shaping itself based on our interaction with it. In essence, reality is not a fixed entity, but something that emerges through our engagement with it. The universe, it seems, is alive with potential, shifting and changing in response to our gaze, and in that gaze it finds its form. This idea that observation affects reality leads us to another profound concept in quantum mechanics. The idea that particles are not confined to one location at a time. Instead, they exist in a superposition, a state where they can be in multiple places simultaneously. This is most famously illustrated by Schrödinger's cat thought experiment. Imagine a cat inside a sealed box with a mechanism that has a 50% chance of releasing poison, depending on the state of a quantum particle. Until we open the box to observe the cat is simultaneously alive and dead, a strange combination of both possibilities. It is only when we observe the system that the superposition collapses, and the cat is either alive or dead, depending on the outcome of the quantum event. This strange idea challenges our everyday experiences. In our macroscopic world, objects are clearly in one place at a time, and the idea of something being in two places simultaneously is absurd. Yet in the quantum world, this behavior is commonplace. Particles can be in two states at once, and it is only through measurement that they take on a definite form. The superposition of states is not just a theoretical concept, it is a real phenomenon that scientists have observed in experiments with photons, electrons, and other quantum particles. But perhaps the most mind-boggling aspect of quantum mechanics is the concept of quantum entanglement, a phenomenon so strange that it has baffled even the greatest minds in science. When two particles become entangled, their states become linked, no matter how far apart they are. This means that the state of one particle can instantaneously affect the state of the other, even if they are light years apart. It's as if the two particles are connected by an invisible thread, one that transcends space and time. This spooky action at a distance, as Einstein called it, defies our understanding of how the universe works. How can information travel faster than the speed of light? How can two particles influence each other instantaneously, regardless of the distance between them? Entanglement suggests that the universe is far more interconnected than we could have ever imagined. The particles in the quantum world do not behave like isolated objects. They are part of a larger interconnected whole. Each particle is inextricably linked to every other particle, a vast web of relationships that extends across the cosmos. This interconnectedness hints at a deeper, hidden layer of reality, one that binds everything together in ways we are only beginning to comprehend. As we explore these strange and bewildering concepts, we are reminded that the universe is not as we experience it in our everyday lives. The quantum world operates on a completely different set of rules that challenge our most fundamental assumptions about the nature of reality. Particles can be in multiple places at once, they can influence each other instantaneously, and their very existence depends on the act of observation. This world is not fixed and certain, it is fluid, unpredictable, and filled with possibility. In a way, quantum mechanics reveals a deeper truth about the universe, that it is not a collection of isolated, fixed objects, but a dynamic, ever-changing web of possibilities. It is a place where uncertainty reigns, where the very act of looking can change the course of events, and where reality itself is shaped by the interaction between observer and observed. The quantum world is a place of infinite potential, a space where the boundaries between what is real and what is possible blur into one. And as we continue to explore this strange realm, we find that the more we learn, the more we realize how little we truly know. The quantum world with all its mysteries is still an enigma, one that refuses to be fully understood, yet beckons us to explore further, to dive deeper into its infinite possibilities. As we near the end of our journey through the strange and perplexing world of quantum mechanics, it's worth reflecting on the profound implications of what we have uncovered. The quantum world with all its mysteries doesn't just challenge the way we view particles or waves, it challenges the very fabric of reality itself. For if particles can be in multiple places at once, and if the act of observation can shape the outcome of events, then what does that say about the nature of the universe as a whole? What does it mean for our understanding of space, time, and even existence itself? One of the most fascinating aspects of quantum mechanics is that it seems to blur the boundaries between the observer and the observed. In our everyday lives, we are accustomed to thinking of ourselves as separate from the world around us, as beings who observe the universe from a distance. But in the quantum world, the act of observing is not passive, it plays an active role in determining the nature of reality. The very fact that a particle exists in a state of uncertainty until we measure it suggests that the universe is not merely a collection of objects that exist independently of us. Instead, reality is co-created through our interaction with it. The universe, it seems, is not a fixed, static entity, but a dynamic, living process, shaped by the very act of observation. This idea has profound implications for how we view ourselves in the cosmos. If the act of observation shapes reality, then we are not mere passive observers, we are participants in the unfolding of the universe. In a sense, each of us plays a role in shaping the very fabric of existence. Our thoughts, our choices, and our actions all have an impact on the quantum world, even if we cannot directly perceive it. This realization is both humbling and empowering. It reminds us that we are not separate from the universe, but deeply interconnected with it, that our lives are part of a much larger ongoing story. Yet even as we explore these profound truths, we are faced with the mystery that quantum mechanics still holds. Despite all the progress we've made, there is so much we do not understand. The quantum world, with all its bizarre behavior and paradoxical nature, continues to elude our full comprehension. Why does observation cause a particle to collapse into a single state? What is the true nature of quantum entanglement, and how does it connect particles across vast distances? These questions, and many others, remain unanswered, and they point to the fact that the universe is far more complex than we could have ever imagined. Perhaps the greatest lesson we can take from our journey through the quantum realm is the recognition that uncertainty is not something to be feared, but embraced. In the quantum world, uncertainty is not a flaw or an imperfection. It is a fundamental feature of the universe. It is through this uncertainty that new possibilities arise, new discoveries are made, and new dimensions of reality are revealed. The very unpredictability of the quantum world is what makes it so rich with potential. It is a place where anything can happen, where the impossible becomes possible, and where the boundaries of reality are constantly being pushed and expanded. As we step back from the complexities of quantum mechanics, we are left with a deep sense of awe and wonder. The universe, it seems, is not just a machine that runs according to fixed laws, it is a living, breathing entity filled with infinite possibilities and mysteries that we have yet to uncover. The more we learn, the more we realize that the universe is not something we can fully understand or control. It is a vast, ever-changing expanse, filled with wonder, uncertainty, and possibility. And yet, despite the challenges, there is something deeply comforting in this uncertainty. The quantum world teaches us that reality is not as rigid as we once thought. It is fluid, dynamic, and open to change. This understanding invites us to live more fully in the present moment, to embrace the mysteries of the universe, and to approach life with a sense of curiosity and wonder. After all, if the quantum world has taught us anything, it is that reality is not fixed. It is a fluid dance of possibility, one that we are all a part of. So as we look up at the stars, as we contemplate the mysteries of the universe, let us remember the lessons of quantum mechanics, that the universe is not a place of rigid certainty, but a place of infinite potential. That reality is not something that happens to us. It is something that we are co-creating every moment, and that in this great cosmic dance, we are not just observers, but participants, shaping the unfolding of the universe with every thought, every action, and every breath. The quantum world is a place where everything is possible, and in that possibility, we find not just uncertainty, but a profound sense of wonder. Water, in its purest form, is a simple thing, a colourless liquid that flows effortlessly, slipping through our fingers, bringing life to the earth. It falls from the sky as rain, courses through rivers and oceans, and sustains every living being. Yet beneath its simplicity lies a mystery so profound that it has fascinated scientists, poets, and dreamers alike for centuries. Water holds memories, or so it seems. It carries with it the echoes of the past, storing the imprints of experiences in ways we cannot fully understand. Think about the last time you stood by a lake or a river, watching the water move. Perhaps you saw ripples dance across the surface, or perhaps the stillness of the water created a mirror, reflecting the world around you. The water was not just an empty space, it was a living, breathing thing, constantly changing and shifting, holding within it the story of everything it had touched. Every droplet, every molecule was once part of something larger, travelling through time and space, gathering experiences like a quiet traveller collecting memories along the way. Water is unique in many ways, but one of the most extraordinary properties it possesses is its ability to remember. Water molecules are constantly moving, constantly in motion, but they never forget. In the world of science, this is known as water's memory. Water has a remarkable capacity to hold the essence of what it has encountered. When a substance, like a mineral or a chemical, dissolves into water, the molecules of water interact with it, creating bonds that shape the substance's energy. These bonds can leave an imprint, a kind of memory, that lingers even after the substance has been removed. This is what makes water so much more than just a liquid. It is a carrier of histories, a keeper of secrets, a silent witness to the events of the world. In the realm of water memory, the mysteries go even deeper. Scientists have observed that water can remember the structure of substances even when they are no longer present. In the 80s, a scientist named Jacques Benveniste proposed an experiment that suggested water could retain the memory of a substance, even after that substance had been diluted beyond recognition. His research sparked controversy, as it challenged everything we thought we knew about chemistry. How could water, something so simple, hold the memory of something it had once contained? And if it could remember, what did that mean for our understanding of the universe? Benveniste's ideas were met with skepticism, and his findings have yet to be fully accepted by the scientific community. However, his work opened a door to a world of possibilities, one where the properties of water could reveal deeper truths about how the universe functions. It is a reminder that the world we see is not as straightforward as it appears. Water, in its quiet simplicity, is a reflection of something much more profound, a universe in constant motion, where even the smallest interactions leave an imprint on time and space. This idea of water holding memories is not just confined to the realm of science. It extends to the stories we tell, the legends we pass down through generations. Cultures across the world have long believed that water has a spirit, a consciousness of its own, capable of remembering and responding to human emotions. In Japan, the concept of water memory is deeply embedded in the belief that water carries the energy of the people who interact with it. Water, they say, can remember the intentions of those who touch it, and it can change its structure based on the vibrations of the emotions and thoughts of human beings. The famous experiment by Dr. Masaru Emoto, in which water crystals were shown to change shape in response to words and emotions, has sparked widespread fascination with the idea that water can be influenced by human consciousness. Although Emoto's work remains controversial and not widely accepted in the scientific community, It resonates with a deeper truth that we may not yet fully understand. There is something about water that feels almost magical, as though it carries with it the echoes of everything it touches. The way it moves, the way it interacts with the world, feels as though it holds stories of the earth itself, of the people, the animals, and the plants that have come before us. Water is not just a substance, it is a messenger, a quiet keeper of time, carrying the marks of everything it has encountered along its journey. Imagine the ocean, vast and endless, stretching across the horizon. Every wave that crashes against the shore holds within it the memory of the distant lands it has crossed. Every drop of rain that falls from the sky has a history of its own, a journey that stretches across time and space. Water is a traveller, constantly moving, constantly changing, yet always remembering. It is a link between the past and the present, between the earth and the sky, a thread that weaves together the tapestry of life. Perhaps the most remarkable thing about water's memory is that it's not a static thing. It does not merely store the past, it shapes the future. The water you drink today has travelled through the earth, passed through countless systems, and encountered countless living beings. As it moves, it gathers new experiences, new memories, and with each encounter, it changes, adapting to the world around it. And when it reaches you, it becomes a part of your own story, a part of your own history. Water is a connector, a bridge between all things, a reminder that we are all part of a greater flow, one that moves through time, through space, and through life. As we stand at the edge of a river watching the water flow past, we are reminded that life, like water, is constantly moving, constantly changing. And just as the river carries the memories of everything it has encountered, so too does our own journey carry the memories of all that has come before us. We are all part of this great flow, and like water, we carry the essence of everything we have encountered along the way. The memory that lives in water is not just the memory of the earth. It is the memory of all life, all time, all experience. As we reflect further on the incredible properties of water, we begin to see how deeply it is woven into the very fabric of life. It is not just a substance that sustains us. It is a part of us, a living connection that stretches from the deepest oceans to the smallest drop of rain. Every time we drink, every time we bathe, every time we touch water, we are connecting to a force far older than ourselves, a force that has witnessed the history of the planet and will continue to carry memories long after we are gone. In this way, water becomes not just a physical necessity, but a symbol of continuity, of the unbroken flow of life and time. Water's memory, as we explore, is not simply a passive archive of past encounters. It is an active living process that evolves with every moment. The molecules of water move constantly, shifting and interacting with the world around them, creating new bonds, dissolving old ones, and always adapting. These shifts are not just physical, they are energetic as well. When water encounters different substances, whether it's minerals in the soil, chemicals in the air, or even the energy of human beings, it absorbs something of that energy, something that lingers, a part of its essence. Consider the way water behaves in nature. Water doesn't just sit still, it moves, flowing over rocks, through rivers, and across the surface of the earth. In its movement, it carries with it the stories of the lands it has touched, the memories of everything it has encountered. This is not just metaphorical, it is literal. Water contains the essence of the environments it flows through, gathering information along the way. And even in the quietest moments, when the water appears still, it is still remembering. The water in a lake or a pond has absorbed the patterns of the wind, the temperature changes, the organisms that live within it. It is a record keeper, a silent historian, holding the secrets of the world it flows through. In many ways, the memory of water mirrors the way our own memories work. Just as we carry the imprints of experiences, moments of joy, sorrow, and everything in between, water too holds the marks of its experiences. And just as our memories can sometimes be triggered by a smell, a sound, or a taste, so too can water's memory be awakened. For scientists, the concept of water memory can be difficult to study directly, but the evidence of its effect is all around us. Water behaves in a way that suggests it can hold the imprint of past influences. It doesn't forget, it adapts, changing in response to what it has absorbed. Whether that's an external force or the imprint of a substance once dissolved within it. The most fascinating aspect of water's memory is its ability to carry the essence of things even after they have been removed. Imagine a drop of water that once contained a mineral, a plant, or an animal particle. Even when that particle has dissolved and disappeared, the water retains a faint trace of it, an echo of its presence. This is why water, even in its purest state, is never truly empty. It is always connected to the world around it, always carrying the essence of life. When water evaporates, the process of separation is not final, is just a change in form. As the water returns to the earth as rain, it brings with it the memories of where it has been, what it has touched. Perhaps most incredibly, water's memory has been explored in the realm of healing. Many ancient cultures have recognized the power of water not only to sustain life but to restore balance and harmony. From the healing springs of ancient Greece to the sacred wells of indigenous cultures, water has long been considered a powerful agent of transformation. It is believed that water can carry the healing energies of the earth, restoring harmony to those who come into contact with it. This idea aligns with the notion that water's memory can hold more than just the physical properties of the substances it encounters. It can hold the energy, the vibration, and the essence of those experiences as well. In modern science, water's memory is still a subject of much debate, but there is a growing body of research that suggests water may play a role in the body's healing processes. Some scientists believe that water can store information about the energetic vibrations of different molecules, which may help the body recognize and respond to illness or injury. While this idea remains speculative, it reflects the larger understanding of water as more than just a passive medium. Water is a dynamic, energetic substance that interacts with the world in ways we are only beginning to understand. It is a force that sustains life, that carries memories, and that has the potential to heal and transform. As we contemplate these mysteries, we are led to a deeper question. What is it that makes water so special, so capable of carrying memories and energies? Is it simply the structure of the molecules themselves, or is there something more? Perhaps, like the rest of the natural world, water is not just a collection of atoms and molecules, but a living, breathing entity, full of potential and mystery. Perhaps it is through the interaction of water with life, plants, animals, and human beings, that its true power is revealed. Water, in its simplest form, is a reminder of the interconnectedness of all things. It is a bridge between past and future, a vessel for memories, and a carrier of energies. It teaches us that nothing is ever truly lost, that everything we experience leaves an imprint on the world around us, and that the flow of time, like the flow of water, is continuous and unbroken. Just as water moves through the earth, gathering memories and stories along the way, so too does life move through time, carrying the imprints of our experiences and leaving behind a trail of memories for those who follow. As we continue to reflect on the profound mystery of water's memory, it becomes clear that this simple substance holds far more than meets the eye. Water, in its unassuming presence, becomes a metaphor for the larger, often hidden forces at work in the world around us. It is through water that we begin to see how life itself is an ongoing exchange, a constant cycle of transformation and remembrance. Water moves through the earth, through life, gathering experiences, holding memories and carrying them into the future. Just as we cannot see every drop of water or every ripple it makes, we often fail to see the deeper currents of connection that move through our lives. Yet much like water, we are constantly influenced by forces we cannot see. Whether it's the energy of our relationships, the emotional currents that shape our actions, or the memories we carry with us from the past. It's almost as though water teaches us to trust in the invisible, to recognize that even when we cannot see something, it does not mean it's not there. Just as water can hold the imprint of something it has dissolved, We too carry the imprints of everything we've experienced. The memories of the past are not gone, even when we cannot see them. They are stored within us, just as they are stored within the water. The idea that water can carry and release energy, as seen in the sacred traditions of healing and purification, suggests that it's not just a physical substance, but a conduit for deeper forces, forces that we may not fully understand. Perhaps the act of healing is not simply about the body, but about reconnecting with the memories, energies, and imprints that live within us. The ancients believed that water was a source of wisdom, and this belief resonates through many cultures and spiritual practices. In Hinduism, for example, water is considered sacred and purifying, with rivers like the Ganges revered for their ability to wash away sin and negativity. In Western medicine, water is similarly seen as a healer, restoring balance to the body and mind. But as we peer into the deeper aspects of water's memory, we start to realize that it is not just about the physical properties of water, but about the way it connects us to the greater flow of life. When we drink water, we are not just hydrating ourselves, we are connecting to the larger web of existence, to the ancient cycles of the earth, and to the continuous flow of time. Imagine, for a moment, the way water flows through a river. It begins at the highest peaks, where the snow melts and the streams begin their journey. It winds its way down, collecting droplets, small fragments of the land, until it merges with other rivers, joining the great ocean. This journey is not just a physical one, it is a metaphor for the way all things move through time, collecting experiences and memories along the way. As we travel through life, we too gather experiences, each one adding to the flow, shaping the person we become. And just as a river can never return to its source, we too are constantly moving forward, carrying the memories of our past as we make our way through the world. Water's memory is a reminder that everything is interconnected. Every drop of water that falls from the sky, every river that winds its way across the earth, every ocean that stretches to the horizon, all are part of the same endless cycle. Water teaches us that nothing is ever truly lost. The water you drink today may have been part of a distant storm in another part of the world, may have flowed through the roots of trees, or been part of the clouds overhead. It has travelled through the earth, across oceans, through the atmosphere, and now it is here, within you. In the same way, we are all connected to the past, to each other, and to the cycles of the earth, whether we are aware of it or not. Water shows us how we are all part of something much larger than ourselves, a continuous, interconnected web of life and memory. This understanding of water's memory invites us to think about the nature of memory itself. How often do we dismiss our own memories, thinking of them as fixed, unchangeable, or irrelevant? Water's memory teaches us that nothing is fixed. Memories, like water, flow and change over time. They are not static, they are part of the ongoing movement of life. Just as a river carves its path through the land, shaping the landscape around it. Our memories shape who we are and how we move through the world. And just as water can cleanse and renew, so too can our memories be transformed, reinterpreted, and reshaped by our experiences. As we consider the memory that lives in water, we begin to see that it is not just the memory of water itself, but the memory of everything it has encountered. Water's ability to carry and retain information is a reminder that we, too, carry the imprints of everything we have encountered. Every experience, every relationship, every moment leaves a mark on us, just as it leaves a mark on the water. These marks are not always visible, but they shape the way we move through the world, the way we interact with others, and the way we perceive ourselves. Ultimately, water's memory serves as a reminder that we are all part of an ongoing flow, a current that moves through time, collecting experiences and memories and carrying them forward. We are not separate from this flow, we are part of it. As we drink the water, as we touch the earth, as we breathe the air, we are participating in a cycle that has been unfolding for eons. And just as water carries the memory of everything it has touched, so too do we carry the memories of everything that has touched us. We are not just individuals, we are part of the great interconnected web of life. Each of us a drop in the ocean of time, carrying the imprints of all that has come before us. And so, as we continue on our journey through life, let us remember that like water, we are always flowing, always moving forward. We carry with us the memories of the past, but we are not bound by them. Just as water can shape and carve the land, so too can we shape our own futures, guided by the memories we hold and the experiences we encounter. Water teaches us that life is not about holding on to the past, but about flowing forward, carrying the essence of everything we have experienced and using it to create something new. Time as we experience it is a constant. It ticks away second by second, minute by minute, hour by hour. We plan our days, our weeks, and our years around it, marking the passage of time with milestones, deadlines, and birthdays. But what if time, this ever-flowing river that seems so steady, is not quite as constant as we think? What if it bends, stretches, or even slows down, depending on where we are and how fast we move? This idea, which sounds like something out of science fiction, is actually a fundamental part of how the universe works. It is the science of relativity, and it reveals that time is far more flexible and mysterious than we could ever have imagined. At the heart of the theory of relativity is the concept that time is not the same for everyone. It is not a universal constant that flows at the same rate for all people, all places, and all circumstances. Instead, time is relative. This means that time can move faster or slower, depending on how fast you are moving, how close you are to a massive object, or even how high up you are in the atmosphere. Time is like a river, bending and curving around the forces of the universe. The faster you travel, the more time stretches, the more the flow of time itself changes. This strange idea was first introduced by Albert Einstein in the early 20th century, revolutionizing our understanding of space-time and the very fabric of reality itself. Einstein's theory of relativity, which comes in two parts, special relativity and general relativity, shows us that space and time are not separate entities. Instead, they are part of a single unified fabric called space-time. And it is this fabric that bends, warps, and stretches in response to the presence of mass and energy. Just as a heavy object placed on a rubber sheet causes it to bend, the presence of mass, like a planet or a star, causes space-time to curve. This warping of space-time is what causes the strange effects we see with time. Imagine for a moment that you are standing at the edge of a large pond. If you throw a rock into the water, it will create ripples that spread out in all directions. The water's surface, which was once smooth, now curves and ripples, responding to the disturbance of the rock. This is how space-time behaves when mass or energy is present. Large objects, like the Earth, cause space-time to curve around them, creating a kind of dent in the fabric of the universe. This is the basis for gravity, the force that pulls objects toward one another. The more massive an object, the more it bends space-time. And just as ripples spread outward on the surface of the water, this curvature affects the movement of objects. It influences the paths of planets, stars, and even light itself. But what does the bending of space-time have to do with time? The answer lies in the fact that time is not experienced the same way in different parts of the universe. For example, imagine that you are on a spaceship traveling close to the speed of light. As you speed up, time begins to slow down for you, relative to someone who is standing still on Earth. To you, the seconds may seem to pass normally, but for the person on Earth, they will notice that your clock is ticking more slowly. This phenomenon, called time dilation, happens because of the way space-time behaves when objects move at speeds close to the speed of light. The faster you move, the more time stretches. This means that while you might experience only a few seconds or minutes on your journey, years or even centuries could pass for someone on Earth. Time dilation has been proven in many experiments. For example, atomic clocks on satellites orbiting the Earth tick more slowly than those on the ground. This is because the satellites are moving at high speeds relative to the Earth, causing time to slow down for them. The faster an object moves, the more time is stretched. It is a counterintuitive and strange phenomenon, but it has been confirmed through precise measurements. The closer you get to the speed of light, the greater the time dilation. This effect is not just theoretical, it is something we can measure and experience in the real world. But time dilation does not only occur with objects moving at high speeds, it also happens near massive objects, such as planets or stars. In fact, the stronger the gravitational field of an object, the more time slows down near it. This effect is a consequence of Einstein's general theory of relativity, which describes how gravity works in the context of space-time. The stronger the gravity, the more space-time is curved and the more time is stretched. This means that time passes more slowly on the surface of the Earth than it does for someone who is far away in space. The difference is small, but it is measurable. Astronauts aboard the International Space Station experience time slightly differently than people on Earth, and this difference has been confirmed by the fact that the clocks on the station run a little faster than those on the ground. This warping of time and space challenges our most basic intuitions about the universe. We experience time as something constant, something that flows steadily and predictably. But the theory of relativity reveals that time is far more fluid than we ever realized. Time bends and stretches in response to the forces of gravity and the motion of objects. It moves faster for some, slower for others, and it can even come to a standstill if you travel close enough to a black hole, where gravity is so strong that not even light can escape. This bending of time is not just a theoretical concept, it has real, tangible effects on the way we experience the world and the universe. As we continue to explore the implications of relativity, we begin to realize that time is not just a human construct. It is a fundamental feature of the universe woven into the very fabric of space-time. Time is not a constant. It is an ever-changing, ever-shifting force that is influenced by the world around us. The faster we move, the more time bends and stretches. The closer we get to massive objects, the slower time passes. And in the deepest corners of the universe, time itself may behave in ways we cannot even imagine. As we continue to explore the mysteries of relativity, it becomes clear that time, once thought of as a simple and constant measure of existence, is far more complicated than we ever imagined. The idea that time can slow down or speed up depending on the conditions of motion and gravity challenges our most basic understanding of how the universe works. But what does this mean for our everyday experience? How do these shifts in time affect the world we live in and our perception of reality? One of the most striking implications of relativity is the way it alters our understanding of simultaneity, the idea that two events can occur at the same time. In our everyday lives, we think of time as something universal. If two events happen simultaneously in one place, they happen simultaneously everywhere. But Einstein's theory reveals that this is not true. The faster an object moves, the more the concept of simultaneity becomes relative. What seems like an event happening at the same time for one observer may appear to happen at different times for someone else moving at a different speed. This is known as the relativity of simultaneity. Imagine, for example, that two lightning bolts strike the front and rear ends of a moving train at the same time. For someone standing on the ground observing the train, it seems that the lightning strikes happened at the same time, since the light from both bolts travels at the same speed. But for someone inside the train, things appear very different. If the train is moving toward the location of one lightning strike and away from the other, the person on the train will observe the strike at the front of the train to happen first. Even though both strikes occur at the same time for someone on the ground, for the observer on the train, the strikes happen at different times. This strange effect is a direct result of the theory of relativity and the way that motion changes our perception of time. This principle becomes even more perplexing when we consider the vast distances of the universe. Light, as we have already seen, travels at a finite speed, about 300,000 kilometers per second. When we look up at the stars, we are not seeing them as they are in the present moment, but as they were when the light first left them, often thousands or even millions of years ago. This means that when we look at distant galaxies, we are looking back in time. The farther away a galaxy is, the further back in time we are seeing it. This stretch of time, this ability to look into the past, is one of the most profound implications of the speed of light and the theory of relativity. But the effects of relativity aren't limited to distant stars. They have real, measurable consequences here on Earth, especially when we think about the way satellites orbit our planet. Satellites in orbit around the Earth move at speeds close to 28,000 kilometers per hour. According to Einstein's theory, the faster an object moves, the slower time should pass for it. And this effect is not just theoretical, it has been measured. The atomic clocks aboard satellites in orbit tick slightly more slowly than those on the ground due to their high speeds. This time dilation, though small, has a real impact on the way we use GPS technology. GPS satellites must account for the difference in time between the clocks on the ground and those in orbit, or else the system would not work correctly. Without this adjustment, our navigation systems would be off by miles. This brings us to a deeper truth about the nature of time itself. Time, it seems, is not a static backdrop against which the events of the universe unfold. It is dynamic, responsive to the conditions of space and motion. The faster we move, the more time stretches. The closer we get to massive objects, the more time slows down. In this sense, time becomes less like a ticking clock and more like a fluid river, flowing and bending in response to the forces of the universe. As we approach the ultimate extremes of relativity, we begin to encounter the strange and mysterious world of black holes. Black holes are regions of space where gravity is so intense that not even light can escape. At the center of a black hole lies what is known as the singularity, a point where the laws of physics break down and the fabric of space-time curves infinitely. Time, as we know it, behaves strangely near a black hole. The closer an object gets to the event horizon, the point beyond which nothing can escape, the more time slows down. To an outside observer, someone falling into a black hole would appear to freeze in time, as if suspended in an eternal moment. But from the perspective of the person falling in, time would continue to move forward normally, though they would be stretched and torn by the immense gravitational forces as they approach the singularity. This strange stretching of time is one of the many paradoxes of relativity. The closer we get to the edge of a black hole, the more we feel the effects of time dilation. The experience of time becomes entirely relative to our position in the universe, to our motion, and to the gravitational forces acting upon us. The time that we experience is not universal, but a personal, subjective experience, shaped by the forces around us. And yet, even as we confront the mysteries and paradoxes of relativity, there is something profoundly beautiful about this new understanding of time. It forces us to question the assumptions we have held for centuries about the universe. Time is not a rigid linear force. It is a fluid, malleable one, shaped by the cosmos itself. The universe is not a clock ticking away in a fixed pattern, but a vast, interconnected web where time stretches and bends in response to the motions of the stars, the planets, and even light itself. In this way, relativity shows us that time, far from being an ordinary part of our lives, is a key to understanding the very structure of the universe. It is a living, breathing force, constantly shifting and changing, shaping our experience of reality. And as we continue to explore the mysteries of time, we realize that the more we learn, the more we uncover about the profound and beautiful workings of the universe. As we approach the final stages of our exploration of relativity, we are left with the most mind-bending and profound questions about the nature of time. What happens when time slows down or stretches? Does it change the very nature of our existence? Does it affect how we experience the world? Or is it merely a theoretical concept, something that happens only in the extreme conditions of space and motion? To truly grasp the implications of relativity, we must look beyond the equations and into the very core of what time means for us as human beings. One of the most striking features of Einstein's theory is that it reveals the intimate connection between time and space. Time is not a separate, independent entity. It is woven into the fabric of space itself, creating a unified structure known as space-time. This insight radically alters the way we think about the universe. Instead of envisioning time as a linear, unchanging river, we now understand that time is a dynamic and flexible part of the universe, affected by the curvature of space. This realization forces us to reconsider our place in the universe and the role that time plays in shaping our lives. Take a moment to imagine what it would be like to experience time differently. Imagine that you are traveling close to the speed of light, moving faster and faster, with each second stretching out before you. While you perceive time moving normally in your own frame of reference, an observer on Earth would see you moving slower and slower. To them, you are aging more slowly, living in what seems like an eternal moment. In your own mind, however, you are still living your life at the usual pace. The seconds pass, the years go by, but they do so in a way that is different from how they are experienced by others. This strange effect of time dilation means that if you were to travel close to the speed of light, you could embark on a journey into the future. By moving at such speeds, you would experience only a small amount of a time, while those left behind would experience the passage of many years. If you were to return to Earth after your journey, you would find that the world had aged far more than you had. This concept, known as time travel in the realm of relativity, offers a fascinating glimpse into the nature of time as a fluid, flexible concept. The idea of time travel, once confined to science fiction, is grounded in the principles of relativity. It's not about traveling backward in time as often portrayed in stories, but rather about experiencing time differently depending on how fast you move. The faster you travel, the more time stretches for you, and the more you can experience a different timeline relative to the rest of the world. This opens up the possibility of traveling far into the future while remaining in the present moment of your own life, as if you were skipping ahead in time without ever moving forward in the traditional sense. But beyond the theoretical possibilities, the implications of relativity also affect how we live our lives in the present. We live in a world where time often feels like an enemy, constantly slipping through our fingers, ticking away faster than we can keep up. Our lives are filled with deadlines, appointments, and expectations, all governed by the steady ticking of clocks. In contrast, relativity reveals that time is far more malleable than we ever realized. It is not something rigid or fixed. It is something that moves and changes depending on the forces around us. This knowledge invites us to think differently about how we experience time. Rather than seeing it as a limiting, unchangeable force, we are reminded that time is a fluid, ever-changing part of the universe. Time is not something we are trapped by. It is something that moves with us, marches with us, and bends with the forces of gravity, speed, and energy. When we understand this, we gain a new perspective on life, realizing that time is not something we can control or conquer, but something that we can flow with, in harmony with the universe around us. As we reach the farthest edges of our understanding of time, we are faced with yet another enigma, the nature of time near a black hole. A black hole is a region of space where gravity is so strong that not even light can escape. Near a black hole, time behaves in an even more extreme way. As an object approaches the event horizon, the boundary beyond which nothing can escape, the flow of time slows down more and more. From the perspective of an observer far away, it would seem as if time stops altogether at the event horizon. The object falling into the black hole would appear to freeze in time, suspended in an eternal moment. But from the perspective of the object itself, time continues normally, albeit with the terrifying reality of being stretched and torn by the immense gravitational forces as it is drawn into the black hole. This paradoxical nature of time near a black hole is one of the most intriguing and baffling aspects of general relativity. It challenges our intuition in ways that defy our everyday experiences. It forces us to confront the limits of our understanding of time, space, and reality itself. As we continue to study black holes and the behavior of time in their vicinity, we are left with more questions than answers. What happens to time inside a black hole? Does it continue to flow, or does it come to an end altogether? These questions remain unanswered, but they serve as a reminder that our understanding of the universe is still incomplete, that time, like space, is a mystery that we are only beginning to unravel. The study of time in the context of relativity, then, becomes not just a scientific pursuit, but a philosophical one as well. It forces us to ask deep questions about the nature of existence, the flow of time, and our place in the vast, expanding universe. Time as we know it may not be the constant, unchanging force that we once believed it to be. Instead, it is a dynamic, malleable entity, shaped by the forces of space, motion, and gravity. It is a force that stretches and bends, offering us a deeper understanding of the universe and a profound glimpse into the mysteries of existence itself. The world of plants is quieter than our own. It lacks the sounds of conversation, the hum of traffic, or the thrum of machines. And yet, beneath their stillness, plants are constantly at work, measuring and responding to the world around them in ways that we rarely notice. One of the most fascinating aspects of plant life is their ability to keep track of time. Plants, it turns out, have a kind of internal clock, a circadian rhythm that allows them to sense the passing of time, to count the hours, even in the absence of direct cues from the outside world. This ability is vital to their survival, helping them coordinate their growth, reproduction, and responses to the changing environment. Imagine, for a moment, a tree standing in the forest. Each day it experiences the rising and setting of the sun. It feels the warmth of daylight and the coolness of night. But while the sun and the moon move across the sky, something else is happening beneath the surface of the tree's bark. Hidden within the cells of the tree, a series of molecular processes are quietly at work, tracking the passage of time. These processes are driven by the plant's internal circadian clock, which helps it to anticipate changes in its environment and prepare for them. This internal clock is not unique to trees. It exists in every plant, from the smallest wildflower to the largest redwood. The circadian rhythm helps plants adjust their behavior to the rhythm of the day and night. Just as animals have evolved to become active at certain times, awake during the day or night, plants too have adapted to specific cycles of light and dark. But what is most remarkable about this internal clock is that it does not depend on the external environment to function. Even if a plant is placed in total darkness, its circadian rhythm will continue to run for a period of time, often with a slight drift in its accuracy. This suggests that the clock is an intrinsic part of the plant, a mechanism deeply embedded in its biology. Plants' ability to sense time and adjust their behavior accordingly is vital for their growth and survival. Their circadian rhythm allows them to regulate processes like photosynthesis, flowering, and the opening and closing of stomata, tiny pores in their leaves. For example, during the day, plants open their stomata to take in carbon dioxide for photosynthesis. At night, they close them to conserve water and prevent unnecessary energy loss. This cycle of opening and closing is carefully timed, in sync with the hours of daylight and darkness. The plant's internal clock helps ensure that it is ready to capture the sun's energy when it is available, while conserving its resources when the sun is not shining. This ability to track time also influences plants' growth patterns. Many plants exhibit a phenomenon called photoperiodism, which means they respond to the length of the day or night. Some plants, for example, will only flower when the day is a certain length, signaling that it is the right time for reproduction. Others may need a specific amount of darkness before they bloom. This sensitivity to the length of the day and night is governed by their internal clock, which helps them time their flowering and fruiting to maximize their chances of survival and reproduction. Perhaps the most striking example of a plant's internal sense of time is its response to the day-night cycle. At night, many plants exhibit a behavior known as nyctinasty, where their leaves close or fold up, mimicking the action of a slumbering organism. The plant is not asleep, but it is preparing for the darkness that will come, just as humans prepare for rest. In the morning, the plant opens its leaves again, greeting the sunlight as it would the first rays of dawn. This daily rhythm of opening and closing is a direct result of the plant's circadian rhythm, which ensures it is active and responsive at the right times. But how does this internal clock work? The mechanism behind it lies in a complex series of chemical and genetic processes that govern the plant's biological functions. Central to this is a set of genes that regulate the plant's internal oscillators. These oscillators work together to create a cycle of activity that roughly matches the 24-hour day. The genes responsible for this cycle are constantly turning on and off, creating a series of biochemical reactions that control the plant's behavior. It's as if the plant has a natural rhythm, a beat that it follows without ever needing to look at a clock. These oscillators allow the plant to synchronize its internal processes with the external environment, ensuring that it's always in tune with the natural world. Interestingly, plants are not the only living organisms to have evolved this internal sense of time. The circadian rhythm is found in almost all living beings, from bacteria to animals to humans. In fact, the biological clock that regulates our own sleep-wake cycle is governed by similar mechanisms. This suggests that the ability to sense time is an ancient and fundamental feature of life on Earth. It is a process that allows organisms to adapt to their environment, to anticipate changes, and to optimize their behavior for survival. Just as animals use their circadian rhythm to regulate when they are active or resting, plants use theirs to determine when to grow, when to flower, and when to conserve energy. The study of plants' ability to keep track of time has revealed not just how they survive, but how they thrive. Their circadian rhythm is a testament to the intricacies of life, showing how deeply interconnected all living things are with the natural rhythms of the world. Plants, it turns out, are not passive entities waiting for the world to act upon them. They are active participants in the dance of life, responding to the changing conditions around them, adjusting their behavior and syncing their processes to the beat of time. In the quiet world of plants, time is not something that passes unnoticed. It is something that they count, measure, and respond to. With an elegance and precision that we are only beginning to understand, plants' ability to sense the passing of time is a powerful reminder of the subtle forces that govern all living beings, shaping their behavior in ways that are often invisible to the human eye. And in this quiet, steady rhythm, plants show us that time is not just a measure of existence. It is an intrinsic part of life itself, woven into the very fabric of every living thing. As we continue to explore how plants count the hours, we begin to realize that their relationship with time is not merely an instinctual response to light and dark. It is a finely tuned process that governs their growth, development, and ability to survive. The concept of time in the plant world is not just a passive observation. It is an active, vital force that shapes everything a plant does. Time plays a crucial role in guiding when a plant blooms, when it sheds its leaves, and even when it faces the external environment, from the shifting temperatures to the gentle sway of the wind. This relationship with time is perhaps most evident in the way plants track the changing seasons. Many plants use a process called photoperiodism, which involves responding to the length of day and night to determine when it is the best time to flower. For instance, some plants, such as chrysanthemums, will only flower when the nights are long enough, signaling that it is time for reproduction. These plants have evolved to know when the time is right to reproduce based on the timing of the sun's position in the sky. Without their ability to count the hours, they would risk blooming too early or too late, when the environment isn't conducive to their growth. In addition to regulating reproduction, photoperiodism helps plants conserve energy. When the seasons shift and the days become shorter, many plants enter a period of dormancy. This is particularly true for deciduous trees, which shed their leaves in autumn to preserve water and energy during the winter months. The timing of this process is crucial. If a tree were to retain its leaves through the winter, it would lose too much water in the cold and dry conditions, weakening the tree and making it more susceptible to disease. The plant's internal clock ensures that it only drops its leaves when the conditions are right, syncing with the natural rhythms of the environment to survive the harsh winter. Even more remarkable is the way plants synchronize their behavior with the movement of the sun. Many plants, especially flowers, follow a process called heliotropism, which means they track the sun's position throughout the day. You may have seen sunflowers turning their heads to face the sun as it moves across the sky. This is not a random action, it is an intrinsic part of the plant's circadian rhythm. The plant's internal clock allows it to anticipate the position of the sun even before the first light of dawn. As the sun rises, the plant's leaves or flowers begin to rotate, ensuring they are perfectly aligned to capture the sunlight as it climbs higher into the sky. This behavior ensures that the plant maximizes its exposure to light for photosynthesis, optimizing its growth and energy production. Interestingly, heliotropism is not restricted to the larger, more conspicuous plants like sunflowers. Many smaller plants also exhibit this behavior. For example, some grasses and legumes use heliotropism to ensure their leaves are aligned to catch the maximum amount of sunlight. This dynamic tracking of the sun throughout the day showcases just how finely tuned plants are to the passage of time. It's not simply about growing, it's about growing at the right time and in the right direction, in perfect synchrony with the world around them. But plants' internal clocks do not just respond to external cues like sunlight and temperature. They also operate on a molecular level, with specialized genes and proteins that control the plant's circadian rhythm. These biological processes are so precise that they can even measure tiny fractions of a second, adjusting the plant's activities to an incredibly accurate schedule. This internal clock runs on a 24-hour cycle, much like the human circadian rhythm, and is responsible for regulating key activities like the opening and closing of stomata, the production of energy, and even the timing of flowering. The molecular basis for this timekeeping lies in the genes that plants use to synchronize their internal process. These genes encode proteins that cycle in a regular pattern, turning on and off throughout the day in response to light. When exposed to light, the plant's proteins accumulate and activate genes that drive certain behaviors, such as the movement of leaves or the opening of flowers. At night, these proteins break down, allowing the plant to rest and conserve energy. This process is so precise that even in complete darkness, the plant will continue to follow its internal clock, drifting slightly out of sync with the external environment, but still following the rhythm that has been encoded in its DNA. Plants also have another remarkable feature that relies on their ability to count time, the movement of their leaves. Known as the sleep movements of plants, this behavior involves plants raising or lowering their leaves in response to the time of day. This phenomenon is particularly noticeable in legumes like the mimosa, which folds its leaves at night, seemingly sleeping in a way that protects it from cold or harm. This movement is regulated by the plant's internal clock, helping the plant conserve resources during the night when light for photosynthesis is unavailable. This sleep movement is not just for protection. It serves several important functions. By closing its leaves at night, the plant reduces water loss through transpiration, conserving precious resources when the air is cooler and more humid. Additionally, these movements allow the plant to better manage its energy stores. During the day, the leaves are open and exposed to the sun, absorbing light and generating energy. At night, they close, helping the plant enter a period of rest and renewal, allowing its metabolic processes to slow down and recover. The synchronization of this behavior with the plant's circadian rhythm ensures that the plant's energy is used efficiently, maximizing its chances of survival. Plants' ability to count time extends even beyond the daily cycle of night and day. Some plants can also sense the changing seasons and adjust their growth accordingly. For instance, many trees and shrubs have evolved to detect the lengthening days of spring, triggering a burst of growth in the warmer months. This response is not random, it is dictated by the plant's internal biological clock, which is finely tuned to the changes in temperature and light that accompany the changing seasons. In the fall, as the days grow shorter and the temperatures drop, many trees prepare for the long winter months by slowing their growth and shedding their leaves. This ability to sense the shifting rhythms of the seasons and respond accordingly is essential for the survival of the plant. By aligning its growth and behavior with the seasons, the plant ensures that it is always prepared for the challenges of the environment, from the heat of summer to the cold of winter. What we learn from plants is not just a lesson in biology. It's a reminder that time is not just something we measure with clocks and calendars. Time is a part of the natural world, embedded in every living thing. Plants show us how to move with time, to flow with the rhythms of the earth, the sun, and the seasons. Their internal clocks allow them to measure the hours, days, and seasons in ways that are essential to their survival, helping them grow, reproduce, and adapt to their ever-changing environment. In this quiet, subtle dance with time, plants teach us that we too are part of a larger, interconnected world, one that moves according to the natural rhythms that govern all of life. As we delve deeper into the intricacies of how plants count the hours, we realize that their sense of time is more than just a passive mechanism. It is an active, guiding force that helps them navigate the complexities of their environment. Time, for plants, is not something that simply passes unnoticed. It is an essential part of their survival, helping them anticipate changes in the environment and adapt to them in ways that are often invisible to the human eye. From the moment a seed germinates to the time it flowers and bears fruit, plants are continually responding to the flow of time, synchronizing their growth and behaviors to the natural rhythms of day and night as well as the changing seasons. One of the most fascinating aspects of this timekeeping is how plants can predict the onset of specific environmental conditions, such as the first frost or the arrival of spring. This ability to anticipate changes in the environment is a direct result of the plant's circadian rhythm, which helps it synchronize its internal processes with the external world. Plants do not wait passively for the seasons to change. They are active participants in the timing of these shifts. They know when it is time to bloom, when it is time to shed their leaves, and when it is time to conserve energy for the long winter months. For instance, many plants that are sensitive to temperature and light cues will initiate the process of flowering when the days begin to lengthen, signaling that spring has arrived. These plants are able to sense the amount of light they are receiving, and through their circadian rhythm, they can measure the length of the day, using this information to determine the right time to flower. This timing is crucial, as it ensures that the plant blooms when pollinators are most active, maximizing its chances of successful reproduction. For plants that rely on pollinators such as bees or butterflies, the exact timing of flowering can make the difference between success and failure. In this sense, plants' ability to count the hours is not just an internal process. It is deeply connected to the broader ecosystem, where their timing can affect the success of the entire food chain. Similarly, plants living in colder climates have adapted to survive harsh winters by timing their growth cycles with incredible precision. For example, many trees and shrubs prepare for winter by slowing down their growth, conserving energy, and entering a dormant state. This process is called winter dormancy, and it is a crucial part of the plant's annual cycle. The plant's circadian rhythm helps it recognize when the days are growing shorter, signaling that it is time to stop growing and begin conserving resources. During this time, the plant will shed its leaves to prevent water loss and reduce the strain on its resources. This ability to accurately predict the coming of winter and to prepare accordingly ensures the plant's survival through the cold months when resources are scarce. Interestingly, the circadian rhythm not only governs the plant's internal processes, but also interacts with the external environment. Take, for instance, the phenomenon of photoreceptor proteins. These proteins are responsible for detecting light and enabling plants to synchronize their internal clocks with the external world. They help plants sense when the sun rises and sets, providing them with the information needed to regulate their circadian rhythm. These photoreceptors play a key role in how plants adapt to their environment. When the plant detects light, it activates the genes responsible for opening stomata or initiating photosynthesis. In the absence of light, these processes slow down, and the plant conserves its energy. By constantly adjusting to the cycles of light and dark, plants optimize their ability to harness energy from the sun while managing their resources efficiently. Even more remarkable is the ability of plants to synchronize their rhythms to the broader environment, adjusting not only to day and night, but also to the seasons, temperature fluctuations, and even weather patterns. Many plants can detect small shifts in temperature or changes in atmospheric pressure, and these changes trigger a cascade of biochemical processes that help the plant prepare for the upcoming conditions. For example, when the temperature begins to drop, plants might slow their metabolic process, reduce the rate of water loss, and increase their resistance to cold. This ability to sense and react to changes in the environment is vital for survival, especially for plants that grow in climates with extreme temperatures. A striking example of plants' ability to respond to the environment is found in the way they prepare for drought. During periods of drought, many plants adjust their internal clocks to help them conserve water. They can alter the timing of their stomachal opening, reducing water loss through transpiration, and adjust their growth rate to minimize water use. By coordinating these behaviors with the cycles of light and temperature, plants ensure that they are using their resources efficiently, without wasting water or energy. Yet even with all these remarkable abilities, the plant's sense of time goes beyond just survival mechanisms. There is a deeper, more intricate aspect of this timekeeping that connects plants to the natural world. Plants' ability to synchronize their internal rhythms with the changing environment is a testament to the deep connection between all living things and the rhythms of the earth. It is as if plants are in constant conversation with the world around them, reacting and adapting to the ebb and flow of nature. Their internal clocks allow them to respond to changes in the environment with a precision that ensures their survival, while also maintaining harmony with the greater ecosystem. The way plants count the hours also provides insight into our own relationship with time. Just as plants rely on their circadian rhythm to maintain their growth and survival, we too rely on the rhythms of the natural world to guide our lives. The rising and setting of the sun, the changing of the seasons, and the cycle of day and night are all part of the greater rhythm that governs life on Earth. By understanding how plants synchronize their behavior with these rhythms, we are reminded that we too are part of a larger interconnected system. Time for both plants and humans is not something we control, it is something we are a part of, a force that shapes our existence and guides us through the ever-changing world. In the end, plants' ability to count the hours is not just about the passage of time, it is about the delicate balance between life and the environment. It is about synchronization, adaptation, and survival. And in this quiet, subtle dance with time, plants show us how deeply connected all living things are to the rhythms of the world. Their timekeeping is a reminder that time is not just a measure of life, it is a living force, one that shapes everything around us and ensures the continuity of life itself. The human brain, in its quiet complexity, is constantly at work sending signals, processing information, and controlling the very functions that allow us to think, move, and feel. But have you ever stopped to wonder how thoughts come into being? How do abstract concepts and fleeting ideas emerge from the sea of electrical activity that flows through our brains? It is a profound mystery, one that scientists have been trying to unravel for centuries. The answer, it seems, lies in the electrical signals that fire between neurons, the very electricity that powers our thoughts. Our brain, despite its soft, squishy texture, is a remarkably efficient electrical system. It is made up of around 86 billion neurons, each one a microscopic powerhouse of electrical activity. These neurons are connected by synapses, tiny junctions that allow them to communicate with each other. At any given moment, billions of neurons are firing, sending electrical impulses through pathways that are constantly shifting and evolving. These electrical signals form the basis of our thoughts, memories, and perceptions. To understand how this process works, we must first look at the structure of the neuron itself. A neuron consists of a cell body, dendrites, the branches that receive signals from other neurons, and an axon, which sends electrical signals to other neurons. When a neuron receives a signal from another neuron, it generates an electrical impulse called an action potential that travels along the axon to the next neuron. This electrical signal is the key to how the brain functions. It allows information to be transmitted rapidly from one part of the brain to another, creating the connections that form the foundation of our thoughts. But what exactly is happening when these electrical signals travel through the brain? The process begins when a neuron receives an electrical impulse from another neuron. This causes a change in the electrical charge of the neuron, triggering the action potential. The action potential travels along the axon, a long, thread-like structure that carries the electrical signal from one neuron to another. As the signal travels, it passes through a series of nodes, or small gaps in the axon, where the electrical charge is amplified and boosted. This process allows the signal to travel quickly, reaching its destination in a fraction of a second. When the electrical signal reaches the end of the axon, it crosses the synapse, the gap between neurons, and triggers the release of neurotransmitters. These neurotransmitters are chemicals that carry the signal from one neuron to the next. They bind to receptors on the next neuron, transmitting the electrical impulse and continuing the flow of information through the brain. This entire process happens in a split second, allowing us to think, react, and perceive the world around us in real time. The flow of electricity through the brain is not random. It is highly organized and carefully regulated. Neurons are not just firing haphazardly, they are following complex patterns of electrical activity that are shaped by our experiences, thoughts, and emotions. The brain's electrical activity is influenced by the environment, our senses, and even our subconscious mind. For example, when we experience a new sensation, such as tasting a favorite food, neurons fire in a specific pattern, creating an electrical signature that corresponds to that particular experience. Over time, as we repeat that experience, the pattern of electrical activity becomes more ingrained, forming a neural pathway that makes the process faster and more efficient. The brain's electrical activity is also highly dynamic, constantly adapting and changing in response to new experiences. This ability to adapt and rewire itself is known as neuroplasticity. When we learn something new, our brain forms new connections between neurons, allowing us to store and process new information. This process is powered by the very electricity that drives our thoughts. As neurons fire and communicate, they strengthen the pathways that form the foundation of our knowledge and memory. But what about our conscious thoughts? The ones that we are aware of, the ones that seem to flow naturally from one idea to the next. Are these simply the result of electrical signals in the brain, or is there something more to the story? This is where the mystery deepens. Scientists believe that our conscious thoughts emerge from the intricate interplay of neural activity. As electrical signals travel through the brain, they activate different regions, creating patterns of activity that correspond to specific thoughts and actions. These patterns are complex and dynamic, involving many different regions of the brain working together. At the heart of this process is the prefrontal cortex, a region of the brain that is responsible for higher-level functions such as reasoning, decision-making, and self-control. The prefrontal cortex is thought to play a key role in the generation of conscious thought. When we think about something, the prefrontal cortex helps to organize and prioritize the information, creating a coherent thought process. This process is not just mechanical, it is influenced by our emotions, memories, and experiences, which add layers of complexity to our thoughts. In essence, the electricity of thought is not just about the firing of neurons, it is about how these signals are shaped by our past, our environment, and our internal state. The electrical activity in the brain also explains why thoughts can sometimes feel so powerful or overwhelming. When neurons fire rapidly and in synchrony, they can generate intense waves of electrical activity, which can manifest as strong emotions or sudden insights. In this way, electricity and emotion are intricately linked, as the electrical signals that drive our thoughts also shape our feelings and perceptions. This connection between electricity and emotion helps to explain why certain experiences, whether positive or negative, can have such a profound impact on our thoughts and behavior. The more we learn about the electrical nature of thought, the more we realize just how finely tuned and interconnected the brain really is. Every thought, every sensation, every memory is the result of an intricate dance of electrical signals, firing and transmitting across a vast network of neurons. This network, like an electrical circuit, is constantly shifting and adapting, allowing us to process information, solve problems, and navigate the world around us. And as we continue to explore the mysteries of the brain, one thing is clear: the electricity of thought is not just a metaphor. It is the very foundation of our existence, the energy that powers our minds and shapes our reality. The complexity of thought, powered by the electricity flowing through the brain, is an ever-evolving mystery. As we dive deeper into understanding how the brain generates conscious awareness, we begin to uncover how these electrical signals are woven into the very fabric of our experiences. Thoughts, memories, and emotions are not isolated entities, but interconnected processes, all influenced by the electrical currents coursing through our neurons. The brain, despite its structure and cellular makeup, is not just a static organ, it's a dynamic electrical system, constantly interacting with itself and the environment, creating a vast web of activity that gives rise to the conscious mind. One of the key features of this system is the ability of neurons to communicate through electrical impulses. But it's not just about the raw firing of signals. There's a rhythm to it, a frequency at which neurons communicate that influences how we experience thought and awareness. These electrical rhythms, often referred to as brainwaves, oscillate in different frequencies, each corresponding to a different state of mind. For example, when we are awake and alert, our brain activity produces high-frequency beta waves. But as we relax or drift into sleep, the frequency of these waves slows, producing alpha and theta waves, which are associated with calmness and deep rest.